So this is how it's looking under the inverter where we need to run the cables. So I've got the cable that comes up to the terminal there for the battery connection. What I'm going to do is I'm going to run that down the wall in conduit somewhere down here. I've got this battery switch, so this is 275 amp continuous battery cut-off switch. So I'll put this here. And now I'm just trying to figure out how to wire that neatly so that the positive comes in and back out again. So what I'm going to do is it's going to go something like this, and then I'm going to conduit all the way down, drill some nice big holes in the floor, and run the positive and negative in separate conduit down under the house, and then all the way down to the battery box. So that's kind of the plan, and how neat it's going to look. It's going to be a little bit interesting, but we'll see how we go. The other thing I suppose first is that what I'm going to do is I'm going to use the cable that came with the SolarX unit, and I'm going to run that down to where it joins to this, and then from this onwards, from the switch onwards, it's going to be a 0 gauge thick cable all the way from under the house to the battery box. So it's going to go from the cable that came with it, I think that's 5 gauge, all the way down to here, and then so it's a short run of 5 gauge, and then all the rest is going to be 0 gauge thick cable. So I need a spot to kind of terminate it. This is a perfect spot to terminate the positive. However, I do need a kind of a spot to terminate the negative, but we'll see how we go. The reason I'm doing the first kind of half meter or so in the smaller cable, the 5 gauge, is mainly because two issues. One is that it's got the plug already on it to fit into the bottom of the inverter, and number two is that I want to have as long as possible run of the 0 gauge cable as possible. However, it is so expensive per meter, and given that you need to buy 2 meters for every meter for the positive and the negative, it adds up extremely fast. So if I can use a short run of the existing cable that came with it, probably the better. But if I put this somewhere like that, it's not too much of a run to the bottom of the floor, so there'll be about a meter and a bit before it starts to go under the floor and come out the other side. So we'll see how we go. So this is kind of a bit of a look before I kind of get started, and then it goes all the way to the battery box or under the floor. So yeah, let's see how we go. Right, so I've just gone under the house and made very sure that there's nothing underneath where I was drilling. We've got insulation all the way underneath the house, so I've had to pull that back because otherwise it gets caught on this and then stops the bit. About 2 years ago, when we were actually doing renovations, I was sticking a big drill straight through the floor to drill out a big hole for the bathroom, and unfortunately it caught on the material that's used for insulation and pretty much ripped the drill out of my hand, breaking my finger. So yeah, this time I'm very sure to make sure there's nothing under here that's going to cause me a problem. So what we'll do is we'll drill through this, and then I'll come back. Right, so after some drilling we have some holes, and we can see through to the ground. It's a little bit of air coming up, so yeah, that's good. A bit messy, but hey, we're good. Right, so under the house here you can see I pulled back that insulation stuff, and we've got our 3 holes. What I've done is I've just put through a Cat 5 cable, and the reason I'm doing that is because I'm going to use this as my initial cable to figure out how long I need to buy the 0 gauge cable, because I don't really want to buy too much of it, given it's about $30 something a meter, and obviously for every 1 meter I need 2. So $60 a meter, it adds up. So what we're going to do is we're going to run our cable first, check the length, cut it to the right size, and then pull it back through, and then buy the correct length of DC cable, and then come back and put it in and run it through the conduit. So this is going pretty much over this way, and it's going to run along there, and you might be able to make out that the battery box is over here. So we're going to go straight through there. So it's not far. Let me run some cable. Right, so now this cable I've got coming out here, And pretty much what I'm going to do is I want to drill. I was actually thinking about putting a big circle, a big hole here, but I'm thinking now that maybe just putting 3 holes might be just as good. Not too sure actually, because I've got 3 conduits to bring in, positive, negative, and then a conduit that'll just have something like network cable in it or something to bring. I could put power out here over the Ethernet, or I could have pretty much anything. So it just gives me some options. So I just need to figure out what size hole I should do here. So either bring the conduit out and then straight into here using and then silicon around it, so maybe a 32mm hole, 3 of those in there, or I do a big hole and use something like a 90-degree bend or a 45-degree bend, like on a big pipe, and then run the conduit to the bottom of that. I have to think about that. And it's pretty much going to come out somewhere along here, so that'll be perfect, and I can run my negative down and my positive up. Just need to think about it. Right, so let's have a look at how the batteries are looking now that they're in here. So as you can see, they are all looking pretty damn good. So that's worked really, really well. If I come back a little bit, it might glare out. But as you can see, they're all fitted in really quite nicely. The bottom one sits on the floor, which, it's not too much of a problem. But it does create a small problem about where I run my negative leads so that it's tidy. I need to figure that one out. I didn't really plan for that. I actually planned for it to be raised off the ground, but obviously because of the height of the box and those issues in the last video that I pointed out, you can see that I'm having to try and fit a 14S where it possibly was only really designed for 10S. But that's okay, we can make it work. I suspect what we'll do is run a negative up to here and then run it across, and that would be the same on all the negatives will come across the bottom of this. That was my thought so far. But either way, so I've got my negative to come this way, and if we have a look at the positive, what will happen is that these will come up to here, and then I'll put a bus bar or something here, and then they'll go along and then over to this piece of wood here, our back piece, which will have our circuit breakers and our main cable that comes from the inverter. So that's kind of the initial thoughts anyway. I've got a little bit of working out to figure out how it's all going to fit in. This actually shows you a good example of how far back it goes. And as you can see, I've got quite a bit of room back there, and that's obviously the same on every row. But let's get wiring, let's wire this thing up. Right, so I've just got back from picking up some cable and some connectors and a whole bunch of other bits and pieces. And so what I've gone with is 0 gauge cable, and obviously black and red. And what I did was I did a little bit of research before actually buying the cable. I was thinking about buying some cable, a whole roll of it, 15 meters off the internet. And when I was looking at it, I was actually just about to buy it, and then I realized it was CCA, and I thought, well, what the heck is CCA versus, why is it half the price almost of normal cable? And that's when I realized that there's a big difference between a CCA cable and the good stuff. So this stuff here, if I actually move it around, in fact grabbing a red one will probably make more sense given the writing's white. So this one here, if it actually focuses, so I'll put it on my leg. This one here is obviously 0 gauge, full spec, and what does it actually say? Oh, there we go. So the key part about this cable is OFC, where it says stranded tinned OFC copper cable. So there's a big difference between OFC and CCA. I'll link some some videos in the description below. And it wasn't until I actually googled the difference between the 3 different types of, say, DC cable that you would use. One being CCA cable, one being OFC cable, and the other one being welding cable. and there's a whole raft of videos that show you the big difference between them all. Welding cable, you've got to make sure that you terminate the ends correctly, otherwise it oxidizes or something like that. CCA cable is the cheap alternative to the good stuff, this being the good stuff. So the real difference is that it's about half the price almost. It's pretty much the cheap version of this. And what it means is that, you'll see in the videos if you watch them, is that it's got a higher resistance, so there's a larger voltage drop. There's a whole raft of other things that it's not good at. It heats up compared to this cable here. At lower thresholds, it melts, and it does a whole bunch of other stuff. So whenever you're buying cables, especially for batteries, and battery boxes and bits and pieces running to your inverter, make sure it's not CCA cable. And if you do have CCA cable, replace it, and you'll notice that you'll have less of a voltage drop across the cable. So yeah, this cable is quite expensive. So I had two options when buying cable. This was option one, just going out and buying exactly the size or the length that I needed. Option two was to buy a reel of cable. This cable here in a reel is about $400 New Zealand, and I would get about 15 meters for that. Now what I've done is I've purchased just the amount that I need. So I've got 5 meters of red and 4 meters of black. 5 meters of red is because it goes higher up in the battery box, so that's why I needed it slightly longer. But if we look at my receipt, and I've got a whole bunch of other connectors and bits and pieces, you'll see that I'm paying $30 a meter. So 200 and what's that? $70 on the top two lines just of this cable. So it's obviously more expensive per meter to buy it not on a big reel. However, the overall cost was much cheaper. So obviously if I bought a whole reel, I'd have to fork out $400 and something. So I think it's closer to $450 or somewhere around there, versus this has only cost me $270 or so. So it was actually, even though it cost higher per meter, I've got the overall cost lower. So overall, that's $350 of battery stuff. So it's one of these things, is that you start building some battery, or you start building your 18650s and your Powerwall and things like that. But then the costs start adding up when you've got to do cabling and other things. Now, obviously, I needed quite a bit of cable, but either way, it certainly adds up with connectors and plugs and bits and pieces. I could have got the connectors and plugs overseas. I would have had to put some more planning into it, and so I've had to pay 10 times the price. But I've got a whole bunch of stuff. If I come into here, so some of these for the battery box, so it terminates there, and I've got the run, so I'll connect all that up and we'll show you that in the next part of the video really. So what I'm doing now is I'm going to pretty much wire this part up here, put the wire in the conduit, and then start feeding the conduit through the hole. That's kind of the first bit of the plan anyway, is to at least get this part done, wire in the conduit, and then we can start pushing the conduit down back through those holes and all the way to the battery box. And if I thought, well, I'll make this the starting point and then kind of work towards the battery box. So I'll go get the other cable that I had with the 175 amp Anderson connector on it, and we'll go from there. Okay, so I've got my big crimper that I actually only got because I looked at DIY Tech and Repairs video when he was talking about this crimper. So I've purchased this crimper about a month and a half ago, so it's delivered in time, so now that's perfect because I need to crimp the big connections for zero gauge. I've also got my smaller one for stripping small cable, and I've got my other crimper that I also got, but I won't be using that at this stage, I don't think. And obviously I've got my length of this is, I think it's 5 AWG 5, I think it is. Now trying to find the actual number on it might be a bit of a mission, because of course the camera is working, so yeah, I can't find it on there actually. Oh, there we go. Yeah, at the start, 5 AWG. So that's the length, that's the thickness of this one. So what I'll be doing is I'll be putting this up on the wall, and then terminating that somewhere along here in this spot, and then all the rest, all the way down the wall, is going to be, and under the floor is going to be the big 0 gauge stuff. So let's get started. So after about an hour, we're slowly getting there. It takes so much time to put termination points on things and everything. So currently I've got it almost kind of wired up, so I've stuck that end on there. That's going to go up on the wall next to that one. That's the cables in the conduit, which was a bit of a mission. Maybe I should have run a cable through the conduit before I tried to put the big one through, but I managed to do that. And now I'm just about to put that switch on the wall and kind of tidy that part up, and then push the cables under the house. So that's that one. If I come through here, you'll see kind of cables just going everywhere really. So I'm slowly getting there. It's a bit of work. It looks easy. It looks like I haven't done much, but I have actually spent an hour doing stuff. So we're getting there. We're definitely getting there. And this is the positive side here. So it's on the end of that, and that's to connect to that switch. So wish me luck. Right, so this is how it's looking now inside. Oh, I'm a bit puffed after doing all that stuff under the house. So these are, I've got 3 cables going. These are just Cat 5 or Cat 6 cables going to the battery box. I'm not too sure what I'll use them for right now, but I thought, well, I'm sure I'll use one, and I can always use one for pulling back cable if I need to, and it's just handy, so I might as well put all 3 in there for now. And we've got our positive and negative. The positive's obviously on the left with the switch, and we've got our terminal there which goes up to there, and that runs down. So I just need to stick these pipes on the wall a bit better. So let's have a look under the house, eh? Right, so that's where it comes out of. Excuse those other cables are a bit messy. All the new ones are in conduit. So it comes up to there, around and down and out. So I drilled a couple of holes in the wood there to go out, but it's not looking too bad at all, I thought. So yeah, not bad at all. Right, so let's have a look where it comes out of, when it comes out of here. So if I just go around. Right, so this is what it looks like when it comes out the side of the house. So I'll put some silicone around that. Mind you, it's hardly ever going to get wet on this part, but that's okay. So that's how it looks there. I had to twist those over, or switch those over, because I actually needed the positive at the top. So we come and look at the battery box. That's where they come out of. So I need to do some vacuuming. But so the positive here will go all the way up, and we've still got enough length there for the negative, and which we still haven't figured out what we're going to do with that yet. And we've got our 3 Cat 6 cables. So yeah, whew, it's exhausting doing all that. So take a quick break. We'll come back to it. So guys, this is how it is now looking. Not too shabby, I must say. I've got to do something with this pile of crap, but apart from that, it's looking pretty good. So I must say I'm happy with that so far. And so that's the inside part done. Now really just the other stuff in the battery box to wire up all the batteries and things. So the inside part is done really. Okay, so I have just been finishing all this wiring, and it has taken me some time. So let's just have a look at what I've got. Got a circuit breaker at the top. This is just a 32 amp one taken from the other in the garage. So what I've got is dual positives coming up across into the top of the circuit breaker, and then that's currently turned off. And then what we've got is a 4 gauge cable coming out, and that's going to a shunt. That's just doing nothing right now, but it's just temporary. It's going to be in a box and other bits and pieces there, so just temporary for now. And then we've got a little bus bar which has got the positive coming in. I'm not too sure exactly the position or where everything needs to go, so I've kind of left enough cable. So potentially that might go up like that eventually. So there's not too much of a bend in the cable, but also I could also make it shorter if I need to, but I'm just not too sure where things are going to sit. And I'm kind of just putting things in place and just making sure that things are going to reach. So as we keep going further down, this is where things come in. So I've put these up to here. I've cut it back down to here for the conduit, and that works quite nicely. Got the negative conduit coming down. Again, I haven't shortened that at all. It can be shortened, but it's actually not too bad in lengthwise. This other one here, it's just got the network cables in. That's just sitting there doing nothing right now. We've got our bottom bus bar at the bottom there, which has got our negative coming off it. It's going to, well, nowhere right now because I've only just screwed that in. And pretty much it's ready to turn on, which is exciting. So I'm almost running out of daylight, and I haven't got any lights in the battery box just yet. So this is probably going to be the next thing to do, is just turn it on and just hopefully it doesn't go bang and there's no fireworks or anything like that. So obviously that's going to sit with a nice cover on the top, so it's going to look nice and pretty and not as messy potentially as the other one that used to be in the garage. So we're trying to make it a bit tidier and neater. So that's kind of how that's looking. Okay, so I'm just putting the negative lead on something. So on the negative bus bar I've got the negative lead, and of course the cables get tangled. Are we serious that it's gone the wrong way? It totally has. Sorry about that. Okay, I'll just switch to here. So I've got the positive, and we've got our multimeter, which is reading 0. So if I touch this on the very top of the, I'm trying to do it looking at the camera there. Okay, so I've got 51.9 currently on battery voltage, which is good. So what we'll do next is turn the circuit breaker on, and this is a good time to stand back a bit. Okay, so circuit breaker's on. 50, oops, glare, 51.2, exactly the same. Cool, so that appears to be all working. So now let's go inside. Just as we do that, you can see that the sun is almost down. So let's go inside. Dun dun dun. Okay, so in theory, what we'll do is we know we're going to have power there. So rather than using the multimeter, I'll just put the camera in a better position. Okay, so I've just logged into this, and I'm just going to check I'm going to lower everything to the lowest for now. So I'll leave that alone for now. I'll leave that alone for now. Max charge current. So I've just set that to 10 amps. So you can pretty much set it to 0, 10, 20, 30, 40 and 50. You can also obviously set it, you can be quite precise, which is quite good. So I'll just leave it on the minimum for now. Now the really cool thing about this inverter is you've got max discharge current. So you can specify how many amps you want to pull from the batteries, and whatever that turns out to be in watts will obviously be limited to how many amps it's set to. So I've just set that to 10 a second ago. So it's a good check. So that's on 10 amps. So this, if I go back into here, max discharge, so this will go all the way up to, well, it can go quite high, can't it? 100 amps. So we'll just set this all the way down for now, 10 amps. Oh, you can actually even go point something. That's interesting. So yeah, that's pretty cool. So if I go back to charger, lithium, enter, lithium, oops. How do we get back to where we were? Oh, there we go. Okay, so we've got these settings in there currently. So that's fine. And the work mode currently is just on self-use, so it will start to use the batteries. So you can choose a whole raft of options here. You can remote control, you can specify forced time use, so when it turns on. And there's, I think in that forced time use, I think there's about 3 different time settings you can set for both on and off the top of my head. Well, that's what the manual says. I've obviously never done this yet. So yeah, okay, so that's done. Battery's reading 0. Let's wait to see a bang. So let's first plug it in. I just had it sitting there. I'm pretty sure it wasn't pushed in. Yep. Alright, try a big ass connection. So that's a 175 amp Anderson that someone else pointed out in one of my earlier videos. Obviously the battery voltage is still on 0 because we need to turn on our disconnect. So currently it's set to off and I just need to switch this across. So let's try that now. So that's onto the on. Perfect. 52.3. Little battery indicators come up. Now the problem is that I don't know what exactly it's doing because I've never done that part before. Status. Charger, no. Load. So anyway, really the end of this video is that it is working, and we'll come back on the next video with what else it's actually, or what I'm being able to set it up with and how it's working. So yeah, that's really successful. Battery is working. I'll just grab, actually, before I end the video, I'll just grab the clamp meter and we'll just see how much current it's pulling. Right, so very quickly, I also thought I'd mention why I've left these out and not put them in conduit. I'll just turn the light on. And the reason I did that is because I need movement to be able to pull the plug in and out of the bottom of the inverter. So having a thick, hard conduit would make it almost impossible to do that. So what I'll do is I will cable tie this to the other one so it is much neater. But it also makes this part much simpler. We put our clamp meter across it, so we'll just go across this one. So it is exactly 9 amps, or sorry, just under 10 amps. Now if I zero that out, 10 amps. There we go. Now it's around the positive. So I can't remember exactly the direction of the power right now. What the clamp meter is saying is minus. I can't remember if this, which is what, but that's okay. It's doing 10 amps. I would suggest it's draining at 10 amps. So let's go have a look at the batteries. Right, so as we come back into here, we throw the clamp meter around this big fat cable. 10 amps exactly. So if it's around the positive, I would suggest, so if I put it that way, it's 10 amps, and if I put it this way, it's minus 10 amps. So I suggest it's probably this way is the correct way in the orientation, but it says 10 amps. So that's really quite cool. So unlike the any other kind of inverters, especially the off-grid ones, you can when you can't specify how much power you want to use from your batteries, with these types of inverters, because it's pretty much the same concept as the one that I had in the garage, that 2000 watt one, where it kind of matches the load to whatever you specify, well, whatever the load is doing. However, this one will let you specify exactly how much current you want to use, and if you obviously just set it to max, it will try and supplement the house load as much as possible. So that all appears to be working, so I'm really excited because that's taken me pretty much a good 7 hours, but that did include going to pick up stuff, and it's really quite neat and tidy. So I'll just finish tidying things up a little bit, and I'll turn things off tonight because I do need to have a play around with the inverter and just figure out how everything works. So yeah, thanks again for watching, guys. I successfully have this working in the battery box, so subscribe if you haven't subscribed, and I'll see you on the next video.